Hi there. In this video I'm gonna show you how Real3D can be used to analyze a dome. In particular, I wanted to show you two useful features in Real3D, namely 3-point member orientation and multi-DOF constraints. To save time, I already created a dome with geometry and loading. Let's look at the bottom view of the model by going to View, Preset View, Bottom. At this moment, all members have default orientations which we can check from Input Data, Members. Here we can see the local angles are zeros for all members. What we really want is to orient each member such that each member's local z-axis will be perpendicular to the plane formed by the two member nodes and the bottom center of the dome. To do that, first select all members by pressing Ctrl+A. Then go to Geometry. Three-point member orientation. Here we need to use the bottom center of the dome as the third point. The coordinates of the bottom center of the dome happen to be 0, 0, 0. Click Apply to selected members. Now, let's go to Input Data, Members. We see the local angles for each member as calculated automatically. Next, we want to assign multi-DOF constraints to bottom nodes of the dome. We need to constrain each of these nodes such that they can only move along the radial direction of the dome. Let's select all bottom nodes of the dome. Then go to Geometry. Multi-DOF constraints. Inclined rollers. Here, we need to give the reference point, which is the bottom center of the dome. This will effectively create multi-DOF constraints which can be viewed from Input Data. Multi-DOF constraints. It's complaining that incline support at note 145 was skipped due to incline direction being parallel to global X or Y axis. We will deal with this in a moment. Next, we need to restrain all dome bottom nodes in Z directions. Again, let's select all the bottom nodes of the dome. Then go to Geometry. Supports. And restrain the Z direction to each of the selected nodes. We can make this support a little bit bigger. For node 145 we will add a support in both X and Z directions. To do that, it is easier to just go to Input Data. Support. We'll just add node 145. And will restrain in Y directions. Please note that support degrees of freedom and multi-DOF constraints at the same node must be orthogonal to each other so that they do not interfere with each other. Now we can perform static analysis. And view results. To find the support reactions for the inclined support, we need to go to Analysis Results. Multi-DOF constraint forces and moments. That is the end of this video. Thank you for watching.